So we're not going to linger very long just talking about coordinates of points in 3 dimensions. But we do need a couple of tools to work with besides just being able to plot a few points. So the first thing we're going to do, as you can tell by the title on the sheet here, is we're going to measure the distance between 2 points in 3 dimensions. So if this point has 3 coordinates, let's just say that has coordinates x1, y1, and z1. Oh, my ones and commas look a lot the same, don't they? And this point down here has coordinates x2, y2, and z2. And we want to find the distance between those. We need some other useful tools. First, I'm going to call this point A, and I'm going to call this point C. And I'm also going to label this corner here B. There are lots of ways I could orient this next picture, but I picked the way that I think will show best on this camera without using fancy holographic imaging. Now, let's say this horizontal distance is x, and this vertical distance is y, sort of like a traditional piece of graph paper. And the depth going backwards, we'll call that z. All right, we're closing in. We're closing in on the tools. Now, if I wanted to measure the distance between A and B, there we go. I could just use Pythagorean's theorem, and I could say, well, the distance from A to B could be written in AB squared is equal to x squared plus y squared. So we have x, y, third dimension. So we use what we commonly call Pythagorean's theorem, but you know there's other names for that especially if you're searching around some of the really solid math websites out there. So, but we're not interested in A to B, we're interested in from A to C. Now, it turns out then that AB, that distance, we could write as the square root of x squared plus y squared. If I were to consider a completely different right triangle, this triangle connects between A and C. All right, let's see if I can make this happen here. Can you see the tilted right triangle? Can you see that tilted triangle? There's a right angle right here. It's kind of hidden behind this vertical edge, but that is a right triangle. This face here is perpendicular to this face here. There's a right triangle there. And I could then say by observation that AB squared, this distance from here to here, plus z squared is equal to AC squared, which is the hypotenuse of this three-dimensional right triangle that I've got back here. Now, let's put it in terms of x, y, and z only. The distance from A to B is the square root of x squared plus y squared, and if I square that, if I make this little observation here, if I square that, I end up with x squared plus y squared plus z squared is equal to AC squared, my students. So therefore, the distance from A to C is equal to the square root of that x squared plus y squared plus z squared. And if we write it in a traditional distance formula format, that distance would be the square root x2 minus x1 squared plus y2 minus y1 squared plus z2 minus z1 squared. Just a little reminder here, you do have a pause button. I do talk too fast, but you have the ability to pause me, maybe even slow me down, but certainly you can go back and watch it again. Now, quick calculation before we sign off of this little segment. If that is our distance formula, let's try an example. What is the distance between this point and this point? We're not going to pretend to draw pictures now. We're just going to do the computation algebraically. So that distance should be, let's see, x2 is 0 minus 3 quantity squared, and 9 minus 4 quantity squared, and 0 minus a negative 2 would be the same as 0 plus 2 quantity squared. Let's see, what does that end up? Square that's going to be 9. 9 minus 4 is 5. That's going to be 25. And 2 squared is going to be 4. What do we have here? Oh, the distance between those 2 points is exactly square root of 38. And before I sign off here, if you're wondering if our distance formula would translate into higher dimensions, 4 or more, the answer is yes, it would. And it's not typically called a distance formula, but it won't be long before you're in a video segment where we do know what you could be talking about when you're using a higher dimension one of these. But in this course, we're going to focus on 2 and 3 dimensions primarily. Okay? Stick around. More 3Ds coming.